be expanding a cube problem, variation number 1. So the problem is, the side of a cube is decreasing at a rate of 0.7 centimeters a minute. At the instant when the side length is 1.3 centimeters, calculate the following. At what rate is the volume changing? And at what rate is the surface area changing? So the first thing we're going to do is focus on part A. At what rate is the volume changing? And remember that here is our cube, and the side length is going to be 1.3 at that instant. And I always kind of write down the rate of the side of the cube. Just in any problem, I want to get down the rate first, which is ds over dt equals negative 0.7 centimeters a minute. So the first thing you want to do, write a finding statement. So you want to find dv over dt for the volume when the side length is 1.3 centimeters. So the first thing you want to do is write down your equation, v equals s cubed, meaning side length times side length times side length. And then you're going to take the derivative of that, so you're going to bring down the 3, and you're going to drop down the exponent by 1, giving you 3s squared times ds over dt, because remember this acts as kind of like an implicit function. Next, you're going to plug in your side value, 1.3. The reason why you're plugging it in after you take the derivative is because it's not constant, it's only at that instant, and it will change. So you plug it in after the derivative, and you're going to plug in ds over dt, which is your rate here of negative 0.7 centimeters a minute. So now you're going to plug those values in, and you're going to have dv over dt equals 3 times 1.3 squared minus times negative 0.7 centimeters a minute. And when you multiply those two things together, you get the volume is negative 3.549 centimeters cubed a minute, because you can use your calculator, and you don't have to round, that's what it is. So at what rate is the volume changing? You have negative 3.549 centimeters cubed a minute. Now, on to part B. At what rate is the surface area changing? So this rate will stay the same. We can keep a ds over dt, and you can keep your picture the same. You don't have to do anything to change those. The finding statement here is find dA over dt, or the surface area, when the side length is 1.3 centimeters. So first you want to write your equation. The surface area is 6s for side length squared. Now when I take the derivative, I'm just going to do dA over dt because the other one is too long. So you're going to take the derivative of it, and you're going to bring down the 2, multiply it times the 6, you're going to get 12s times ds over dt, which is the derivative of your side length, and then you're going to plug in 12 times your side length, which is 1.3, so you're going to get 15.6 minus negative 0.7, which is the rate the cube is decreasing. You're going to multiply those two together, and you're going to get the surface area to be negative 10.92 centimeters.